Hey guys, my name is Lauren, and today we're going to be talking about neuroscience and its correlates with sign language. Let's jump right in. A bit of background. Fingerspelling is considered the alphabet of sign language. It's used primarily to spell out words that don't have a standard sign. Evidence shows that ASL fingerspelling may be critical for integrating word learning and reading ability in deaf children. So deaf children are brought up using standard sign language, and when they're ready to start learning how to read, they're taught how to fingerspell to bridge the gap. Previous studies have been conducted in British Sign Language, which is a two-handed fingerspelling alphabet. In contrast, American Sign Language is a one-handed fingerspelling alphabet and may have a different representation in the lexical system. There were three main hypotheses within this study. The first being that American Sign Language signs would engage the left supramarginal gyrus more than fingerspelling would in deaf individuals. Second hypothesis was that less skilled signers would recruit more right hemisphere regions than skilled signers would. The third hypothesis was that fingerspelling and printed words would both engage the visual word form area with orthographic processing in a similar way. So how did they do this? Well, they recruited several deaf individuals who could perform ASL and several hearing individuals with no prior knowledge of ASL. They performed several semantic decisions tasks involving printed, fingerspelled, and signed stimuli on a deep level and on a surface level to control for visual information. What they found was that printed words increased activity in the brain for both hearing and deaf individuals, which shouldn't be surprising considering both could read. In contrast, fingerspelled words activated more regions in the deaf group than in the hearing group, particularly in the left frontal and temporal cortices, the right insula, and the middle occipital cortex. Hearing individuals only received a significant information increase in the bilateral middle temporal cortex. ASL signs showed a significant increase in activity in the brain. Fingerspelled words in particular showed increased activity compared to ASL signs in the visual word form area. When pulling all of this information together, they saw that fingerspelled and printed words had similar activations in the brain, particularly in the inferior frontal gyrus, the insula, the medial superior frontal gyrus, for deaf individuals. Similarly, fingerspelled words and ASL signs also showed similar activation, particularly in the frontal and temporal cortex for deaf individuals and not so much for the hearing individuals. A negative correlation was found with ability to fingerspell and to perform ASL and activation in the right hemisphere. So a lower ability to perform ASL was linked to a higher activation in the brain. This illustrates here just that words with ASL translation, so words that have specific signs, have different activation than words that would need to be fingerspelled in order to be conveyed efficiently. If we turn back to our hypotheses, we see that ASL signs did engage the SMG more than fingerspelled words did, which supports the idea that the SMG is involved in phonological processing for symbols. They also found that poorer fingerspelling and ASL ability was related to an increased activation in the left hemisphere, and therefore it suggested that increased visual and spatial attention was needed in order to address that lack of information. Finally, fingerspelled words activated the visual word form area, which suggested its role in mapping orthographic structure onto lexical representations, similarly to how printed words do so in hearing individuals. What does this mean? Well, comprehension of fingerspelled words, printed words, and ASL signs all demonstrated activity that was similar and distinct. The deaf group showed activation for fingerspelling in ASL in the visual word form area. The hearing group did not engage the visual word form area for these stimuli, which reinforced the idea that the visual word form area is active for stimuli that have meaning, lexical meaning. Those who were hearing did not have that lexical meaning associated with their signs, so they didn't have that activation. There was cortical overlap for fingerspelled and printed words in deaf participants. This indicates that both word types engage in a common lexical semantic network and may access the same lexical representations. Words that did not have an ASL translation, such as fingerspelling only, were slower to be processed in both deaf and hearing individuals. These all support the hypothesis that printed and fingerspelled words are linked for deaf readers in the lexical semantic representations through the visual word form area in the brain. Thanks so much for listening, guys. I hope you have a good day.